Hi everyone, in this video we're going to talk about applications of right triangles. So that just means word problems. So hopefully by the end of this video you can use trig ratios to solve application problems involving right triangles. So for each problem we're going to draw a picture or a diagram, usually just a right triangle, write our trig ratio equation and then solve it. So first thing before we get started with that is that we have some new terminology right here with angle of depression and angle of elevation. So the angle of elevation starts from the horizon, okay, and you're going to go up for the angle of elevation. If you're talking about the angle of depression, it starts from the horizon and it goes down from there. Okay, so both of these angles right here are congruent. So just remember that. That means they're the same. So here we go. Example number 1. It says, at a certain time of day, the angle of elevation of the sun is 44 degrees. Find the length of the shadow casted by the building that is 30 meters high. So first thing, we know that we have a right triangle. So let's go ahead and draw it. Okay, and something that might help you is if you make this right here look like the building. So here's my building. It has some windows. Okay, they're going to have oval windows, I guess. All different kinds of windows. Okay. So, and here's the door. Boom. Okay, we have the sun, which is somewhere over here, casting a shadow of the building. Okay, what we know is that our building is 30 meters high. So this is 30 meters right here. So this entire length right here is 30 meters. Okay, we know that the angle of elevation of the sun is 44 degrees. So from the ground, it goes up, and that is 44 degrees. And we want to find the length of the shadow. Find the length of the shadow. So the length of the shadow is going to be this distance right here. So I know that I have 30 degrees. I know I have my angle. Let me switch up my colors. Okay, so I have my angle, 44 degrees. I know that the opposite side is 30. And I want to find this adjacent side right here, which is the length of the shadow. So if I think about SOHCAHTOA, okay, I see that I have the opposite side and I'm trying to find the adjacent side, which means I'm using tangent. So I'm going to have tangent of 44 degrees equal to my ratio of 30 over x. So this is where we can switch the tan 44 and the x, and that gives me x equals 30 divided by tan 44. So now this is the part that we type into our calculator. So when we go to our calculator, we have to make sure that it is in degree mode. So I see mine right here under the home and 1.1, it says RAD, which is not the correct mode. If you're using the handheld calculator, it's going to be on the top right corner. It should say DEG. If it says rad like mine, you'll go to that little gear bar. You'll use your mouse in the top right corner. Go down to your angle and switch it to degree. And then hit done. Okay, so now we're going to type in. We had 30 divided by tan 44 gives us 31.065, which turns that into 0.7. So x is equal to 31.07 meters because that's the unit of measure that we have. Okay. Example number 2, the top of the lighthouse is 120 meters above sea level. The angle of depression from the top of the lighthouse to the ship is 23 degrees. How far is the ship from the foot of the lighthouse? So we have our lighthouse, we have our ship somewhere over here, and this right here. Okay, now it said that the lighthouse is 120 meters above sea level, and we want to find how far the ship is right here. Now, the information they gave us is they said the angle of depression is 23 degrees. So you have to make sure that you go down right here and know that that's 23 degrees. Well, if that's 23 degrees, okay, then that makes this angle also 23 degrees because they're congruent angles. Okay. So, I am going to see that I have the opposite side and I have the the adjacent side. I'm getting ahead of myself. And so if I think about it, SOHCAHTOA, I am going to use tangent. So that would be tan of 23 is equal to 120 over x. Okay, again, it's where I can go ahead and switch here. So it should be x equals 120 over tangent 23. So I'm going to go ahead and let you type that into your calculator. Okay, and let's see what we get. 120 divided by tangent 23, and we get 282.70. 282.70. And we have meters. Okay, moving on to our next example. A 20-foot ladder is leaning against a wall. The base of the ladder is 3 feet from the wall. What angle does the ladder make with the ground? So make your triangle. So we know we have a 20-foot ladder. Okay, that's leaning against the wall. And the base of the ladder is 3 feet from the wall, so 3 feet here. What angle does the ladder make with the ground? So here's the angle right here. So we know that we have the adjacent side. We know that we have the hypotenuse. So we're going to use, if we think about it, SOHCAHTOA. We have the adjacent and the hypotenuse, so it should be cosine. So we have cosine of theta is equal to 3 over 20. This is where we use trig inverse, and we get theta is equal to cosine inverse of 3 over 20. And we're going to type that into our handy dandy calculator. So remember, to get the trig inverse, you hit the trig button on your yellow calculator and it should just pop right up. Or you can hit and hold down cosine, and then you get that -1, and it's 3 over 20. And we get 81.37 degrees. So theta is equal to 81.37 degrees. Okay, looking at the next one, how tall is a bridge if a 6-foot tall person is standing 100 feet away and can see the top of the bridge at an angle of 30 degrees to the horizon? So we have a person here, okay, that we know is 6 foot. Okay, he's staring at a bridge. So this is my bridge. Okay, so we see this little triangle right here. Okay, it says that the angle is 30 degrees to the horizon, so that would be this right here. And he is standing 100 feet away. What we want to know is how tall the actual bridge is. Well, first, we have to find this piece right here, and we have to add the 6 feet after we find that piece to take into account how tall the person is. So we know, or we want to find the opposite side. We know the adjacent side. So if we look at our SOHCAHTOA, we see that we're going to use tangent. So we have tangent of 30 equal to opposite over adjacent. This is where we multiply both sides by 100. Okay, so we get 100 tan 30 equals x. So go ahead and type this into your calculator and see if you get the same answer as me. So that should give you 57.74 equals x. But the height of the bridge, so the bridge is, if I add 6 feet to that, going to be 63.74 feet tall. And that would be my final answer because we wanted to know the actual height of the bridge. Okay. Boom. Moving on to the last example. And if you have any questions, please make sure you're writing them down and make sure you ask. That way you can get help. So in a movie theater 150 feet long, the floor is sloped so that there is a difference of 30 feet between the front and the back of the theater. What is the angle of depression? So we have a movie theater. Okay. We know that it is 150 feet long, and from the front to the back, it's 30 feet. Okay. So we want to find the angle of depression. So if we think about it, angle of depression means it goes down. So this is this angle right here. But remember, it's congruent to this angle right here. So that makes it easier for us. So we know the opposite side. We know the adjacent side. So if we think about SOHCAHTOA, okay, I'm going to use tangent. So I have tangent of theta equal to opposite over adjacent. And then this is where I use trig inverse, which would be tan with the -1 of 30 over 150. Okay, I typed that into the calculator. You type it in, make sure we get the same thing. You should get 11.31 degrees. Okay, so again, if you got that, cool. Hopefully you're good with this. If you have any questions, please let me know and I will help you out. That's it for this video, and I'll see you in the next one.